Hi, welcome to 13.5 binomial probability, um, college math. And I know some of you are struggling, and it's been kind of a tough road. But fortunately, this is the end of the probability, and the other couple of sections will be pretty easy. And this section won't be too difficult either. So maybe there's light at the end of the tunnel. I am dropping 4 quizzes. They should show up probably tomorrow or the next day that these quizzes were dropped, which might help 4 or 5, maybe even. And this should help your grade a little bit, bring it up. And these would be the worst quizzes, dropping the lowest scores. So maybe that'll help some too. If you still are failing at that point, or you feel you need to drop, remember November 27th is the last day to drop. But that's during Thanksgiving break, so you have to kind of, and you're going to have to initiate it on your own. So you have to check if the office is open or whatever. But hopefully it will be, and hopefully you won't have to drop. Maybe your grades will come up. I know you've been struggling, you've been working at it. It's not the easiest thing, all this probability and stuff. Remember, probability is just the number of successes, number of successful attempts, uh, over the total number. Thanks. So, what we're going to do is look at a certain kind of probability, which is kind of a formula driven thing, and it's just a matter of being able to put it in a formula. This would be a lot easier. This is called binomial probability. And it is kind of, the title sounds kind of scary, but it's not really as bad as some of the other stuff you've been doing. Okay, binomial probability. And what this is about is just basically there's a couple of things. Number one, then there's only two outcomes when you do binomial probability. It's kind of like flipping a coin. You either get heads or tails. It's like shooting a basketball. You either made it or you missed it. And that's what we mean by binomial. Bi means there's only two choices, either success or failed. You bought a lottery ticket, either you won or you lost. That's what binomial probability is about. So it's a little bit easier than some of the other probabilities, like what's the probability of drawing a red card out of the deck or something like that. It's a little bit easier than that because there's only, you know, either you got it right or you got it wrong, and the probability of getting it right and the probability of getting it wrong. The other thing is there has to be a fixed number of trials. You can't just do these forever. You have usually you flip a coin 50 times and it's going to come up 25 times heads and 25 times tails. And the success rate is always the same. It doesn't change. It's always the same. If it comes up heads or tails, you got a 50-50 chance, right? Heads 50%, tails 50%. It's not going to change. The second time you flip it, they're kind of independent events. The events are independent of each other. It doesn't matter the first time. It's like shooting a basket 5 times. The first time you either made it or you didn't make it. The second time you either made it or you didn't make it. The third time, it doesn't matter what you did the first 2 times. You either made it or you didn't make it. It's playing a football game. Either you won it or you lost it. It didn't matter what you did 5 weeks up to this point. It's this game. You either win it or you lose it. So it's a much easier type of things. So these are examples of things that are not binomial probability. They're on page 711. like for instance, rolling a die until a 6 comes up. No, you have to roll a die a certain number of times. If you're going to roll it 10 times and count how many times 6 comes up, well, that's fine. But you can't just continually roll it. Okay. A student takes a course and earns an A, B, C, D, or F. There's too many choices. You only have 2 choices. Either you get it right or you get it wrong. You select 4 cards from a deck. Okay. Now, either you select 1 card or you don't select any. So that's basically what it is. And the ones we're going to do are binomial probabilities. So we're going to take a look at a problem right here, see if we can figure this out. And we're going to give you a little probability that this happens. Let's pick a little bit easier one than that one. Okay. So we're going to use a formula. This is your probability formula. Sometimes we write it this way. B N K P. Okay, we'll talk about that later. What this means is this particular, what we're going to do, well, we do it on an actual problem, and we'll show you what all these things stand for. And then the probability of that happening is, here's the formula. I'm looking for the formula. NCK, combination, huh? We're going to use our combination key on the calculator. This times P to the K. Well, I know this formula is going to look hard, but it really isn't as bad as you think. And 1 minus P to the N minus K. I know this looks really confusing. It's totally confusing. But this is on, let's see, where is this formula? Somewhere in the book, you got it. That's the formula we're going to be using anyhow. So it looks it does look a little tricky. It's on the bottom of page 712. Okay. So it looks a little bit hard, but we're explaining what it means. It's pretty easy. Okay. So I'm going to do it on a problem here. Let's try this one. Read this, okay. Example, a new drug that is 75% effective is given to 20 patients. What is the probability that exactly 15 people are going to benefit from this drug? Okay, so we're going to give this drug to 20 people. We're going to see either it works or it doesn't work. We're going to see if it works for 15 people. So we have a set number of outcomes, 15, and we're going to see based on its probability, we're going to figure out the probability that it is successful on these 15 people. So let's start off with, okay, how many patients are there altogether? There's 20 people we're going to test this on. So 20 is our number of tests, and K is the number of successes. 15 people we want to be successful. And P is the probability it's going to be successful, which is 0.75. All right. So this is N, this is K, 15 out of 20. The probability of that happening is 0.75. So we have 20 people. We're going to test on 15 out of 20. It should be, that's our rate that we're going for. And our probability rate is 75% usually. At least that's what the manufacturer claims. So now we're going to write this as 20 C 15, right? Oops, here, let's put a 0 there. 20 C 15, 20 people, 15 successes, The probability of success is 0.75, and we want this for 15 people. So this is the probability of success. Now we're going to figure out the probability of fail. If it's effective 75% of the time, then how many times is it not effective? 25%. Think of this as a percent. These have to add up to 100%, or 0.75 and 0.25 have to add up to the number 1. So these two powers have to add up to 1. The number of successes and the number of losses. Okay? 15, we're raising this to the 15th power. That's the success rate. But the failure rate, these two numbers have to add up to 20. So 15 plus 5 add up to 20. So these two numbers must equal 20. These two numbers have to add up to 1. The first one is your success rate, 15 times. And then this is, see, we're not using 1 minus p. We're kind of doing that on our head. The number 1 minus 0.75 would be 0.25. N minus k is just 5. These two numbers add up to 20. 5 plus 15. So it's a little bit easier than what it looks like in the formula. So now how do I do this? Okay, I'm going to turn on my calculator. Hope you can see this okay. So first of all, I want to do 20C15. So let's clear this out. We're going to go 20, hit our probability key, slide it over to NCR, equals, then put in our 15, times 0.75 raised to the 15th power, times, and this is your raised to key, 0.25 raised to the 5th power, equals, and there's your answer, 0.2023. If you want to convert that to a percent, it's about 20%. You have a 20% probability that it's going to be successful on all 15 people. Seems kind of low, doesn't it? Well, it might be a little low because you're trying to get it on all 15 people that it is totally successful, and it isn't always successful. It's only successful 75% of the time. So that's basically the idea behind it. Okay. Let's try another one and see if we can do it. So this was example 3 in your book about the drugs probability. It was on 713. So let's write down our formula. Let's see if we can remember it. Binomial probability, number of successes or number of attempts. N is the number of attempts. K is the number of successes, and this is your success rate. Then it's going to be number of attempts, C, successes, times the probability of success, which would be K, times the probability, P minus 1, or 1 minus P, I should say, of failure to the N minus K. Okay. It's a little bit daunting, the formula still, huh? And this would be P, not 0.75 P. Sorry. Okay, so let's try another one. It says Maria has fallen behind in her anthropology class. Sounds familiar. And her instructor has announced a pop quiz consisting of 10 true-false questions. She's got to get 6 or more correct to pass this quiz. What is the probability of passing just by guessing? Well, let's find out. the probability of getting, she needs to get 6 or more, just by guessing. Okay. If she guesses, how many questions are on this test? 10, huh? And she needs to get at least 6 right. And what's the probability of that happening? Okay. And that's a pop quiz. They're true, false. So what's the probability on a true, false quiz? You either get it right or you get it wrong. It's like flipping a coin. It's either 50-50. You got a 50% chance on a true, false question that you're going to get it right. You got a 50% chance you're going to get it wrong. Okay, let's put it into our formula. This would be, N would be 10. C, it's a combination, 6. You could use your combination formula. You can use your calculator. I go over the combination formula in just a second. And then the probability of success is 50%. And you want that on 6. And the probability of failure is also 50%, huh? But it's only going to be raised to the what power? 4, because these two numbers, 4 and 6, have to add up to 10. So 6 plus 4, 10. So let's calculate that out. Now, if you don't have a calculator and you have to calculate out the, this would be 10 factorial over 10 minus 6 factorial, or 4 factorial, times 6 factorial. So it's 10 factorial over 4 factorial, 6 factorial. Okay, but it's easier just to use your calculator. All right. So I already got it in here almost, but I'm going to clear it out. Okay, I'm going to go 10. Probability. Unfortunately, it's always this one that you need, so slide it over. And we're going to do it for 6 attempts. Equals. Times, I guess I didn't need to hit the equal, but I did. 0.50 raised to the 6, power up 6, times 0.50 raised to the 4th. So the probability of her getting 6 correct isn't too great. We're just rounded off to 2 decimal places, 0.21. Well, let's carry it out to 4. 0.2041. Not great, but it says 6 or more. So what's the probability she's going to get 7? Maybe she does better than she thinks. So now she's going for 7. This would be 10 C7, 0.50 to the 7 times 0.50 to the 3rd. Now, don't ask me where these formulas come from. I have no clue. Clear. Okay, 10 C, gotta slide it over, 7 times, I'm not going to, 0.50 to the what? 7th times 0.50 raised to the 3rd. 50-50 chance, 0.50. It has to be in decimal form, though. Well, not too great. 0.1172. Well, maybe she did even better than that. She got 8 right. Probability of 8. 10 C8. 0.50 to the 8th. 0.50 to the 2nd, huh? All right. That's where you want a calculator. I'm going to go up here. See, I got 10 NCR 7, so I'm just going to slide over and change that 7 to an 8. I'm going to slide over 50%. This was a 7. I'm going to change that to 8. And this was 0.50. I'm going to change that 3 to a 2. That way I don't have to redo this whole thing. And that came out to be 0.0439. And it said greater than, so let's try it for 9 times. Maybe just by sheer guessing, she got 9 right. Wow. Normal odds are 50-50. It's going beyond the normal odds. 0.50 to the 9th, 0.50 to the 1. So again, I'm going to use my calculator. I don't hit clear. I want to go up here, 10. I'm changing this 8 to what? I'm going to go higher, 9. I'm going to change this 8 again to a 9. And I'm going to go over here and I'm going to make my losses less. So instead of 2, I'm going down to 1. And that'd be 0.0098. I'm going to round it up, 0.0098. And then finally, I'm going to do the last one. What has she got by just sheer guessing? She guessed 10. 0.50 to the 10. What do I do here? This would be 0.50 to the 0. And we do want to put that in there because anything to the 0 number is 1. So, I mean, it may work if we don't put it in, but I'm going to put it in 10. Probably, oh, I shouldn't have erased it, huh? Let's see if let's clear this out. See if I still have the old one in. I do. Okay, 10 NCR. I'm going to go up here, but it's going to be a little hard to put in a 10, so I have to hit second insert. 1, 0. Clear. Yeah, kind of goofed it up. Okay. Times 0.50 to the 10. I'm trying to put this so you can see it, but it's kind of hard. 10 times 0.50. And we just put the 0. Raise to, no, make sure you hit the raise to key, and then don't just put a 0 because then it is 0 out the whole problem. It's pretty small, 0.0009, but it has a 7, so I'm going to go 0.00. Instead of 0.9, I'm going to raise it up 1, so that'd be 10. Okay, now what I'm going to do is I'm going to add all these numbers together. So she has better odds, 6 or better. So we're going to add all those numbers together, 0.2051 plus 0.1172. You can see it's a little time consuming, 0.0439 plus 0.0098 plus 0.0010. So she has actually increased her chances to about 38%. Still not great, but it'd be better to guess than not leave it blank. So on true false, you always want to guess because you still have a 50-50 chance. The chance of her getting those 6 out of 10, even though it's a 50-50 chance, the probability of her getting 6 out of 10 is only 38%. 6 or better. 6 or better out of 10. The probability of just getting 6, exactly 6, would be about 21%. But the probability of getting 6 or more would be a little bit higher. It'd be about 38%. So that's what they did on this one. They figured the probability of each one, and then they added them all up at the end. We added all these together and got this answer. So probability, huh? And that's basically the idea behind it. We're not going to do this other stuff. So that's all there really is to it, you know. Here's one more example. We'll find the probability of rolling exactly 2/7 in 5 rows of the dice. You're rolling the dice 5 times. What's the probability it's going to come up with 2/7? Probability of 2/7 rolling 5 times. So you have to have a set amount of times. So let's look at our formula again. We're going to call this, how many attempts are we going to make? 5. How many successful attempts do we want? 2 out of 5. What's the chance of rolling a 7 though? Okay, what combinations come up with 7? There's a 1 and a 6, a 6 and a 1, 2 and a 5, 5 and a 2, 3 and a 4, and a 4 and a 3. You have 6 chances out of, how many are there altogether? Do you remember? 36. So that's 1/6. 1/6 is, you could leave it a fraction, but you know, most of us don't like to do it. So the probability of just rolling a 7 alone, not just 2 times, but just once, is about, we'll give you an advantage, 1.17. Okay. You only have about 17% chance that it will come up a 7. That's the best odds, best probability you can get. Okay, so this is, let's see how we wrote it. 5C2, right? These two numbers. And the probability of success, 0.17 to the what power? Second, not the fifth. Second. Times the probability of non-success. So that'd be 100, that'd be 1 actually. 1 minus 0.17, huh? That'll be 0.83. And unfortunately, that's raised to the third power because these have to add up to 5. So let's see where that comes out to be. Well, we don't want that one. We want to hit not that one. Let's go with probability here. Let's slide over. But before we do that, let's put in our 5. Probability, not that one. Combination 2 times 0.17 raised to the second times failure 0.83 raised to the third, because those had to add up to 5. 0.65, almost the same thing, huh? 0.165, or about 17%. So the probability of rolling 2 7s 5 times is about the same as rolling 1 7. Kind of weird it came out. It might be a little bit less. Remember, we rounded this up a little bit, but pretty close to 0.17. So an interesting little problem. All right. Well, give these a shot. That's all there really is to it, is putting it into this formula. Success, this is the wins, this is the losses. Probability of a win, 0.17. Probability of a loss, 0.83. You're looking for a power of 2, 2 chances to win, unfortunately 3 chances to lose, because these two numbers have to equal the 5. Okay, maybe this will be a little bit easier. It's a more of a formula type thing.